Okay, so in this video, we're going to learn how to create a dynamic array of any size using a command called malloc, which stands for memory allocation. And once we create this dynamic array, then we're going to traverse the array using pointer notation. You may also hear it called pointer arithmetic. And then we're going to use the dereference operator for an int pointer to display the value stored in the array. Now, for this particular project here, we're going to have two functions. One to set up our dynamic array, to set up the values and to assign them. And the other one is to display the values in the array. So with that, let's go ahead and get started. Okay, so the first thing we're going to do is we're going to go here in the main. I'll make some space here for myself. And I'm going to declare an integer for the size of the array, or the length of the array. But I'm not going to assign a value to it, and I'm going to use a variable. I'm going to ask the user to provide the size of the array. So let's say it's the number of test grades. Then I'm going to ask the user, hey, how many test grades do you have? And then they're going to assign that. And then with that information, we can set up the memory for that array. So we'll need a integer for the size. And for this particular example, we're going to use, we want to create an array of integers. So I'm going to use an int pointer. But if you wanted to create an int of chars, if you wanted to create an array of chars or an array of floats, then you would use a float pointer or a char pointer. So I'm going to call this numbers. And I'm not going to assign anything to it yet. It's going to have it as int numbers like this. And once we can ask the user, so let's ask the user, printf, and we'll ask him enter the number of items. So this is where we'll get the size from the user. So scan f, and then we'll do %d, like this, and then the address operator for size, and then semicolon. Alright, so the user will supply the size. Once we have the size, then we can go ahead and set up our array dynamically using the malloc command. Alright, so what we're going to do is we're going to get our pointer here, and we're going to assign it to equal malloc, and then malloc is going to take an argument here in the parentheses. It's going to be the size of the array times the size of each element of the array. So let's say I'm working with an integer. An integer takes up 4 bytes in memory. So then I'm going to multiply 4 bytes times the size, times the number that the user provided. So to do that, you're going to use another function called size of. And then in parentheses, you put the data type. So in this case, I'm working with ints. So I'm going to put an int for size of. If I was working with floats, then I would put the size of a float. Or if it's char, the size of a char. Alright. So then with this equation here, and this malloc function, it'll create the array for us with the number of elements using the correct size of an integer. So let's say the example is, let's say each integer is 4 bytes and the array is of size 5. Well, then this would allocate 20 bytes of memory because 5 times 4 is 20. Alright. Now, the only thing about malloc is that what it returns is it's going to return a void pointer. So we have to do a typecast. So here in parentheses, you have to put int pointer. So that way it'll convert what this function returns. It'll convert it to an int pointer, and then that will be assigned to numbers. And the address of numbers is going to be the address of the first element of our array. All right, and that's the same thing for any other array, a regular array. It's usually the first address. It's the address of the first value that's stored in it. Okay, so this will create our dynamic array. So I'm going to put a little comment here. Dynamic array. Okay, so that's set up. So then the next things we're going to do is we're going to call a function to assign the values. So we'll get the values from the user. Okay, and then after that we will call a function to display the values. And then whenever you do use the command malloc, you have to also free the pointer. So this is an important part, so don't forget to do this. So you're going to do the free command and the name of your pointer, which is going to be numbers, like this. And then semicolons. Right, so then once you allocate the memory, once you finish using it, then you have to free that memory. So to avoid any errors or problems later, you want to make sure that you use this command here. Okay. So with that, let me just put a comment here. I'll just put here deallocate memory used for dynamic array. Okay. So with that, the next thing we're going to do is we're going to code out our function to assign the values and then the function to display the values. So that's what we'll do next. Okay, so let's go and do our first function, the setup function. Now, for the parameters here, I'm going to need an int pointer for numbers. So this pointer will represent my array. And then I also need a parameter for size. Okay. And then once I have that, then what I'm going to do is I'm going to create a for loop here. Or actually, before I create the for loop, let me create a variable for count. And then I will do my for loop. So I'm going to set count equal to 0, while count is less than size, and then count plus plus. Okay. So then here I'm going to start asking the user for the numbers. So then I'll do printf and then enter value, and then I want to print out the number, or I'll do it like this instead, so you can kind of see it like that. Then I'm going to do scanf, and then here I'm going to do %d like this. And then here I'm going to put the address of the first element in my array, which is going to be numbers. So I'm going to put that here. Numbers. Okay. And it's already an address, so I don't need to put the address operator. And then, but the problem is here, if I need to somehow increment this array, I need to somehow traverse it. And that's where I'm going to use pointer notation or pointer arithmetic. So if I do numbers plus plus, then it's going to go to the next 4 bytes. So the first 4 bytes, I'm going to put a value there. Then I'm going to do numbers plus plus, and then unlike a regular integer or regular number where it goes up +1, here we're going to go to the next 4 bytes. And then if you do plus plus again, it'll go to the next 4 bytes until we reach the end. right? So this is one way of doing it. I'll show you a different way later, but you can do it this way. So then as the loop traverses the array until it reaches size, then it's going to go from the first 4 bytes, then to the next 4 bytes, and then all the way till we get to the end, depending on the number of elements in the array. Okay, so that's how you would set that up. Then in order to test this, I'm going to have to also do the display function. Now the display function will be similar. So let me go to the display function here. I'm going to do the same thing. Okay, in size. So I'll have my pointer, my int pointer. And it doesn't matter where you put the I always put it there, but I actually meant to put it here. Okay, there you go. Alright. So then again here I'll set up another counter or count. And then I'm going to do another for loop. Okay. Count equals 0. Well, count is less than size. And then count plus plus. Okay. So you'll notice here we're working with an array, but we didn't use the subscript operator. We didn't use the brackets this time. Right. So if you're using pointer arithmetic or pointer notation like this here, then you won't need the subscript operator. So that's how you know if you're doing one or the other. Okay. So here, now that we have the values in the array, we can go ahead and display them. So here I'm going to do print f. Then I'll do something like value %d like this equals. So it's going to display value 0 is or equals. And then I'll put another %d here. And then I want a new line. Something like this. So then this first format specifier here will correspond with the count. I'm going to do count. Oh, and I meant to do that up here as well, so I'll add that in a little bit. So that'll be for count, and then here this is going to be the value in the array. So here's numbers. Remember that's an int pointer, right? So I have to dereference this pointer to display what it's pointing to. So to do the dereference operator, you got to use the asterisk like this. Okay. And then that'll display the first value. Then we have to traverse the array using pointer arithmetic. So then I'm going to do numbers plus plus like this. And let's say you want to go backwards too. You could do numbers minus minus, and then that would traverse the array in the opposite order. Of course, that doesn't work unless numbers is already at the end of the array. If you try to go minus minus from the beginning of the array, then you're going to end up in who knows where and probably receive an error. Okay, so I need to do the same thing up here where I wanted to display the count. So I'll put count here like this. Okay, so notice that we're doing the plus plus. We're not using the subscript. We're not doing sub count or sub 0, sub 1. We're doing it by dereferencing the pointer itself. Okay, and the only thing about this approach is that the pointer for numbers is changing because we're reassigning it. So it starts at the first element, that goes to the second element, then the third, then the fourth. And so then this address is actually being changed. But it doesn't really matter because the address of the first element of the array is already stored in the variable here in the main. So even if we modify it here in the function, it won't hurt anything. Okay, but you got to be aware of that. So I think these functions are okay. I don't think we missed anything. So now I'm going to go here and I'm going to call the function. So I'm going to call the setup function. And you're going to pass in your numbers array and you're going to pass in the size. And then we're going to call the function to display the value. So I'm going to do display and then numbers size. Okay. So with that, let's try it out. See if it works. All right. So then from here, let me compile. So GCC dynamic -o. I can call this program. And there's enter. No errors. So ./program. All right. So let's say for this array, I want to enter 3 numbers. So enter value 0. So I'll enter 40. Value 250, and then 60, and then we display the values that are stored in that array. So it's working as we expected, but we're going to add a few things. The other thing I want to do is I want to see the address of these values, so that way you can actually see the pointer notation in action. Alright, so let me go back to my code here. And let's see how we can do this. Maybe we can do something like, well, yeah, we can do something like this maybe. I can put it next to it, maybe in parentheses. Now here I'm going to use a different format specifier for a pointer, so that will display an address. So then now here I'm going to add comma. I'm going to add numbers without the asterisk. So I'm not dereferencing it. I'm actually displaying that the pointer itself. So that way I can see the address. And that way you can see how it's incrementing by 4 bytes every time I do the ++. Okay. So then let me go ahead and save that. Exit. Let's see if this works. Okay, so no issues. So let's do 2 this time. So 78 and 54. Okay. So here you'll see the values, and then here you'll see the memory address, and the address of the first element in the array is going to be 80. The address of the second element is 84. So you see how it went up by 4. You see it here. So let me show you something else. Let me run this. Let me go back to my code here. And now that this is working. So here in line 41, I want to display the address of numbers here. So what I'm going to do is I'm going to do printf. And then I'm going to put something like address of numbers. So I want to see what the address is. And then I'm going to do %p again. And then I'm going to do numbers like this. Alright. Oh, let me do the new line. Okay. So we'll do that. Let me go ahead and save. Exit. Let's compile this. Let's take a look at it. Okay. So I probably should have cleared the screen, but that's okay. So this time I'm going to put 5 elements. Okay. So the address of the first element was going to be start at 80. So you'll notice the addresses are going to be different every time, right? And your address is going to be different than mine. So this is just, assigned randomly. However, just the first one's assigned randomly. After that, it's going to be consecutive. So after that, it'll be every other 4. It'll be every 4 bytes. 43, 23, 56, 78, 98. Okay. So here we saw the first address, or the address of numbers, which was the address of the first element in the array. So that's where it was AA80. And when we print out the array, you'll notice that as well. It's the same address here. So that kind of proves our point. And then notice how it goes from 0 to 4 to 8, but then all of a sudden it goes to C. Well, why does it go to C? Well, because here this is a hexadecimal number. That's why. Hexadecimal has 16 digits, not 10 digits like we're used to. So C is actually 12. So 0, 4, 8, 12, and then it goes back to 16 or back to 0, and then it repeats. Alright, so that's why you'll see the letter C here. So hexadecimal has 16 digits. So instead of after 9, instead of going back to 0, or then it'll do 10, but 10 in hexadecimal is the letter A. Number 11 in hexadecimal is B. 12 is C. D is 13. E is 14, and F is 15. So you'll see F as well, depending on where this starts. But that's why you see letters. Okay. The other thing I want to show you is, let's go back to our code. All right. So here in the display function, we're displaying the values as they were inserted in ascending order. But let's say you want to go backwards. Then we'll notice here that we incremented numbers plus plus. We incremented it. Now, what if we decrement numbers? So let's try that. So then I'm going to do count equals 0, count less than size. See, the count will still go from 0 to whatever size is. That's fine. But I'm talking about what happens when we do the minus minus here. So we're going to type kind of the same thing again, but this time we're going to go in the opposite direction. So print F. Then I'm going to do value sub %d equals %d. Then I want to display the address. So P like this, and then /n like that. Then I'm going to put in the count. I'm going to dereference the numbers like this, and then I'm going to do numbers, so display the address. So same thing that was up here, type that out again. But here I'm going to do something different. I'm going to do numbers minus minus. Okay. So we'll see what that does. I'm going to save this, exit. Alright, so I've compiled it. Let me enter 3 items. And then 45, 67, 100. Okay, so the first time we display it in order, but then here we ended up getting 0. I'll explain why. So we got 0, 167. Okay, so I know what happened here. So we're off by 1. So let me go back. So I'm glad we did this little experiment today. So what ended up happening is, as we're running this function, we're doing plus plus every time, And then after I displayed the last element in the array, I did plus plus again. So now it's off by 1. So if we want to display this in backwards order to get it at the right location, I'm going to have to do an extra numbers minus minus like this. So then that'll set it back to the last element. And then now when I run the loop, it will do it in the correct order. Okay, so it was off by 1. Alright, so then let me do Control X, let me compile this. Alright, so again 3 elements, 77, 66, 100. Alright, so the first time, the first for loop displays it in correct order. Then I did numbers minus minus to go back. And then finally here I displayed 0, 66, and 77. The only thing that's off is going to be right here, because I guess I do need to go for count and then do it backwards as well, so that way this makes a little bit more sense. Even though the numbers are correct, but the index here is off. So we can fix that real quick. So here I will do, I think if I do count size, and then while count is greater than size like this, and then count minus minus. There you go. And then now that'll display the, oh, but I did it on the wrong one. Oops, sorry. I meant to do it on the other one. Okay, sorry about that. Okay, so right here. So I'm going to set count equal to size. And then here, while count is greater than size, and then count minus minus. So that way when we display the index here in the square brackets, it'll display it backwards. Alright, so let's try this again. Compile 3, 67, 88, 99. Oh, it didn't display anything. Maybe I'm off by something. Hold on. Let's check my array again. Let's see what's wrong with my for loop. Okay, so I set count. I set count equal to size. So let's say the size is 5. Okay, so I'm actually going to want to do size minus 1, because let's say it's an element of 4 arrays or 5 arrays, then it's going to go from 0 to 4, right? So size is 5 though, so I want it to start at size minus 1. And then here count, instead of count greater than size, I'm going to say while count is greater than 0. Actually, I'm going to try this. I'm going to try count is greater than or equal to 0, because I want to display the 0 at the end. So we'll try this, see if this works for us. Okay. Now let's compile one more time. Okay, so let's try 3 elements. And then we'll do 1, 2, 3. There you go. So we do 0, 1, 2, 3, and then we display backwards as 2, 1, 0, 3, 2, 1. Okay, so that's actually working for us now. Okay, so the other thing I want to show you is a different way of doing the pointer arithmetic or the pointer notation. So let's go back to our code here. I'm going to do this. Let's go back here. And in this example, we did the plus plus, numbers plus plus to increment the pointer. Alright, that's going to be one of the most common ways of doing it. The only problem with it is that it changes the actual pointer itself. So it is modifying it. So there's a different way of doing it where it won't modify the pointer. So you could do it like this: numbers plus count. Numbers plus count. And so here it's going to start off at numbers, and then plus 0, which is going to be the first element. Then it'll go plus 1, which will be the second element, and then the third element, and so on. And you could do it that way. Now think of it as adding 4 bytes. So the first time it's going to add 0 bytes, the second time it's going to add 4, the next time it's going to add 8 bytes. So you can think of it that way. Now I find the plus plus to be a little bit easier to understand, but you're going to see it both ways. So you got to know both. Okay. So if you increment the pointer plus 1, then that'll take you to the next element of the array. Okay. So then once we do this, we're also going to do it here under the display. We're going to change the notation a little bit. Now here for the minus minus and going backwards, I'm going to comment that out. That's just FYI for your information. So let me comment this out. Okay. So then here we're going to do the same thing, except when you dereference it, you have to use parentheses. So here you'll do pointer numbers plus count, like this. So this will get the correct address, the correct pointer, and then you're going to dereference the entire thing. Because if you put the parentheses over here, or if you don't put parentheses at all, then you're going to dereference the pointer. So then let's say it's a certain memory address and that's pointing to the number 5, and then you do 5 plus 1, then you're going to get 6. It's not what we want, right? So we want to increment the whole pointer first and then dereference it. Okay. So, and this will be the same thing as the plus plus, except the only thing is that the address won't change. The pointer won't be updated. Alright, so let's try it out, see if it still works. So let me go back here. Okay, compile that. Okay, so no error so far. Perfect. Alright, so let me run that. Let's do 3 elements. Okay, so then I'm going to do 54, 64, 74. Right, and still works exactly the same way. Okay, so let's go back to our code, and yeah, and I mean, I guess we could have done the same thing here. You can do the same thing doing the well, because the count is going backwards, so it would actually be the same code. It would look like this instead. All right, but that's going to be it for this video. I want to thank you for watching. I know it's kind of complex topic. I encourage you to practice it, try out different things, and that way you get comfortable with pointer arithmetic, get comfortable with pointers, get comfortable with addresses. Any questions you have, please shoot me an email. All right. Thank you very much, and I'll see you in the next video.